Today we're going to finish up chapter 2, so without further ado, I'm just going to jump right in. A quick reminder of what we talked about last class, because it was last class and you may have forgotten. So we were looking at the demand curve for healthcare, and the first thing that I mentioned at the outset of last class was that it's plausible that the demand for healthcare is vertical, and for a long time we just sincerely did not know, as an economist, as an economics profession, what the slope of the demand curve for healthcare looked like. And it's really difficult to uncover what the true demand curve in the world looks like in terms of its slope, because people who have different price levels that they're exposed to are different in ways other than the price level that they're exposed to. So the RAND health insurance experiment was this randomized control trial that kind of gave us the first evidence on what the demand curve for healthcare looked like. And the research team at RAND came up with, they came up with a lot of results, but the two main conclusions that I want to kind of reinforce to you are that, one, they determined that the demand for healthcare does in fact slope down. So that means people are sensitive to the price. However, the big caveat here is that how steep the slope is depends on which good you're looking at. So for medical goods that are really necessary, the demand curve gets pretty steep and it almost approaches a vertical line. And then for goods that are pretty discretionary, so things like Band-Aids, the slopes can be pretty flat. So people, if the price of Band-Aids is $15 a box, they're just not going to buy them. And so how steep the slope is depends on the good. And the reason this is important is because if you're a policymaker and you would like to move the market to a particular level of healthcare consumption, maybe you think that 100 units of healthcare is kind of like the sweet spot for making the country as healthy as possible, then in order for you to move the country towards that particular quantity that you're interested in, you have to know how steep the demand curve is. Because if the demand curve is very, very steep, then you move the price a whole lot and you're going to get very little movement in the quantity. If the demand is pretty flat and the downward slope it's very, very defined downward slope, then if you as a policymaker move the price a little bit, you're going to get the market to really respond in terms of changing the quantity a lot. Okay, so we talked about all of that kind of conceptually last class. So what we're going to do today is try to provide some structure to this by using an equation to get quantitative values that we can use to kind of analyze price sensitivity a little bit more sharply. So the tool that we use in economics to quantify price sensitivity is elasticity of demand. So the idea is that using this equation is useful because the equation spits out a number, and the number tells you effectively how sensitive people are to the price. And so if we can compute this for different markets, we can look across different markets what the elasticity of demand is, and then we can have a little bit of a cleaner way of saying this is how much a policymaker would need to change the price in this particular market in order to realize a particular change in the quantity demanded. Okay, so on the screen is the equation for elasticity of demand. It looks kind of hairy, but it's actually not bad at all. So I'm just going to explain in very generic kind of language what it's measuring, and then we can practice using it later in class. So the elasticity of demand, first of all, it's a ratio. So in the denominator is the percent change in the price of a particular good, and that is what anchors the elasticity. So everything is divided by the percent change in the price. That means you're kind of scaling everything by how much the price changes. And in the numerator is the percent change in the quantity demanded. So what the elasticity of demand does is it moves up and down, the whole ratio enlarges or decreases based on how sensitive consumers are to price changes, the denominator. So conceptually, think about what it would mean if people were very, very sensitive to the price, or if the demand curve was kind of flat. Well, what that would mean is that if you change the price a given amount, then there's going to be big fluctuations in the quantity demanded. If you look at the ratio, that simply means the numerator is going to be really big. So anytime the magnitude of the elasticity of demand is large, that is the same thing as saying that people are very price sensitive, and that is an elastic demand. It's a relatively elastic demand because people are sensitive to the price. Think about what it would mean if the demand curve was very steep or close to vertical. If you had a very steep demand curve, that would mean that if you change the price by a given level, the change in the quantity demanded would be very, very tiny. And so in terms of the ratio, that would mean the numerator is small. And so as a result, the overall ratio would be very small, and the elasticity of demand would have a magnitude that is very small. So anytime the elasticity of demand is big, that means consumers are price sensitive. The demand is elastic. Anytime elasticity of demand is small, in terms of a magnitude, that means that consumers are relatively insensitive to the price and the demand is inelastic. Okay, one thing to note about the sign of the elasticity of demand, if the demand curve slopes down, that means anytime the price goes up, quantity goes down, and in reverse. So anytime price goes up, quantity goes down, anytime price goes down, quantity goes up. So because price and quantity are the numerator and the denominator, that means the numerator and the denominator are always going to have opposite signs. So if the denominator is positive, if the percent change in price is positive, then as a result, the percent change in quantity is going to be negative. And so the whole ratio is going to be negative. And the same thing works if the percent change in the price is negative. That means the percent change in the quantity demanded is going to be positive. And so elasticity of demand is always going to be negative. But what we're interested in when we're thinking about how sensitive people are is not necessarily the sign, because the sign should be negative. It's just how big the number is. So we're looking at a magnitude. Okay, so the elasticity of demand is going to be bounded by negative infinity and 0. All the values between negative infinity and 0 are negative. And so again, you're just looking at how big that number is. At the extreme, you can have a demand that is perfectly elastic. If that is the case, the elasticity of demand will be negative infinity. And graphically, that means the demand curve will be a horizontal line. So that means people are super, super sensitive to the price. To kind of mentally unpack this, look at the ratio real quick and think about what that would mean. So if people are very, very sensitive to the price, that means if you take the denominator and you just nudge it a tiny, tiny bit so that the nudge in the denominator approaches 0, then people are so sensitive that that tiny nudge is just going to cause them to really, really change their quantity demanded. So the change in the denominator is going to approach 0. The numerator is going to be enormous, and so the whole ratio is going to kind of explode to infinity. And that's why a perfectly elastic demand is going to have an elasticity of negative infinity. On the other end of the spectrum, if you have a demand that is perfectly inelastic, that's another way of saying consumers are not sensitive to the price, then the elasticity of demand is going to be 0. And visually, this is going to correspond to a vertical demand curve. So again, to kind of internalize this, look at the ratio real quick. If you have a perfectly inelastic demand, in other words, consumers don't care about price changes, then in the denominator, you can increase the price millions and millions of percents, and the quantity demanded is not going to change. So the denominator could be super, super big. The numerator is going to be super, super tiny. And so at the extreme, if people are perfectly insensitive to the price, then you change the denominator by whatever magnitude you want. The numerator is going to be 0 because there's going to be a 0% change in the quantity demanded. And so the whole elasticity is going to be 0. Okay, so that is kind of what the formula is. Anytime you're measuring a percent change in anything, the way you do it is you just take the difference between the two levels that you observe and you anchor that by the initial level. So for the elasticity of demand, the percent change in quantity demanded is simply equal to the second quantity demanded that you observed minus the first quantity demanded that you observed, and then you anchor that by the initial or the first quantity demanded. And then it's the same structure for determining the percent change in the price. So if you can kind of memorize the pattern, it's a little bit easier than trying to drill all of the exact equations into your mind. Okay, so one thing that I want to point out about the elasticity of demand equation is, as you can see from on the screen, we have subscripts which denote which quantity and price came first and which one came second. Okay, that's slightly problematic at times, and the reason it's problematic is because in order to calculate the elasticity of demand, that implies that you know which price quantity coordinate preceded another price quantity coordinate. Sometimes when you're working with data, you might see two price quantity coordinates, but you don't know which one came first and which one came second. There's not a chronology that's in the data set. And so this is problematic because you're going to have to pick one to be the first and pick one to be the second. And depending on what your choice is, you're going to get a different number for the elasticity of demand. So to kind of demonstrate this, suppose in your data you have two price points that you observe. So hypothetically, let's suppose there's a vaccine for COVID-19. It rolls out next year, and in one city they charge $15 per shot, and in another city they charge $10 per shot, and then you can kind of observe how many vaccines people demand. Okay, so we've got these two price levels in the data, $15 and $10. If you're trying to calculate the elasticity of demand, and in particular if you're trying to figure out what the denominator is, so you want to know the percent change in the price. If you just kind of willy-nilly decide I'm going to treat the $15 as the first price and $10 as the second price, then if you move from $15 to $10, the percent change in the price is negative 33%, and that is what you would plug in for the denominator of the elasticity of demand. Okay, if, on the other hand, you just kind of willy-nilly decided I'm going to use the $10 as the first price and $15 as the second price, then if you move from $10 to $15, that's a 50% increase in the price. And so that's what you would plug into the denominator of the elasticity of demand. And so now we have a discrepancy in what the denominator is because of the differing sequence of coordinates that we're using. So what that means is that if you have data and you have prices and quantities, but you don't know which prices and quantities precede the other ones, then the choice that you make in terms of which coordinates to treat as the first ones are going to influence the value that you get for the elasticity of demand. Okay, we have a fix for this. So what we use as an alternative to elasticity of demand in situations where we don't know chronology, or we don't know which coordinate came first and which one came second, what we do is we use the formula for the arc elasticity of demand. And that's up on your screen right now. And basically, the only difference between elasticity of demand and arc elasticity of demand is that in the elasticity of demand, when you're calculating the percent changes in either prices or quantities, you anchor everything by an initial level. So if you look back at the equation for elasticity of demand, the numerator is the difference between Q1 and Q2 divided by Q1. Okay, so now in the arc elasticity, the numerator is Q2 minus Q1 divided by Q1 plus Q2. So the reason this kind of fixes the problem of having discrepancies in the value of the elasticity when you don't know sequence is because if you have two numbers, so if you have 5 and 6, and you add them together, it doesn't matter whether you add 5 plus 6 or 6 plus 5. You still get the same value. And so the arc elasticity, instead of anchoring everything by an initial quantity when we're unsure what the initial quantity is, we're going to anchor everything by the sum of the two quantities that you observe. So quick, just kind of a summary of all that I said in the last few minutes is anytime you have a problem or anytime you have data where you know for sure which price quantity coordinates came first and which one came second, in those situations, use the elasticity of demand formula. In situations when you have a problem or data and you do not know which coordinates came first and which ones came second, you just got a set of coordinates, then in those situations it's appropriate to use the arc elasticity of demand. Okay, so the final kind of point I was going to make in chapter 2 is we have this tool now to figure out kind of how sensitive people are to the price of healthcare. We call it elasticity of demand. And one thing that a health economist would be interested in is, okay, now that we think, based on mostly the results from the RAND health insurance experiment, that people are sensitive to the price of healthcare, then something you might ask yourself is, well, okay, if we have price sensitivity, then if a policymaker made healthcare free, well, then we think that would cause people to consume more healthcare. Would that cause people to be healthier? So maybe if it's true that this price sensitivity exists, then a policymaker could make their nation super, super healthy by just making the price of medical care super, super cheap. Okay, how would we answer this question? So think back to the RAND health insurance experiment. In the RAND health insurance experiment, the researchers gathered a whole bunch of families. They randomly assigned them effectively different prices for healthcare. And what they observed is that for families that had different prices of healthcare, they consumed different amounts of medical care. Okay, think about what the researchers should have observed if what is true, and we don't know this, but we want to figure it out, but if what is true is that cheaper medical care makes people healthier, then think about what the RAND experimenters should have observed in the data. If the price of healthcare affects health, then what the researchers should have observed is that for the groups of people that had cheaper medical care, at the end of the experiment, they should have had better physical health. Conversely, the groups of people who had to pay more for health care, at the end of the experiment, they should have had worse physical health. Okay, what would the researchers, or what should they have observed if the price of medical care makes no difference for people's physical well-being? If that's what's true about the universe, then what the RAND researchers should have observed in the data at the end of the experiment is that the people who had cheap medical care should have had exactly the same level of health at the end of the experiment as people who had to pay a lot for their medical care. So the researchers, they were clever enough to recognize that people would be interested in this question of whether the price of healthcare makes a difference for health. And so very early on in the experiment, they published a paper in the New England Journal of Medicine that looked at whether or not there were any kind of health disparities after the exposure to different price levels across the groups that were exposed to different price levels. So they were doing exactly what I just explained. They took everyone who had different random assignments to co-payment rates, and then they looked at the end of the experiment. They knew the groups differed in terms of how many times they went to the doctor. They looked at whether they also differed in terms of how healthy they were at the end of the experiment. Surprisingly and kind of depressingly, the researchers found that the price of healthcare made, in most cases, absolutely zero difference for the health of the people. So the folks who had basically free medical care, yes, they went to the doctor more, but at the end of the experiment, they really weren't any healthier than the people who had expensive medical care. There are a couple of exceptions. One that was kind of funny, I guess, to read in the New England paper was they said at the end of the experiment, the people who had free medical care had better corrected eye vision. So in other words, if you got free medical care, you got glasses. And so in that respect, you're healthier. You can see better if you have a lower price for health care because you can afford glasses. But this is kind of, I mention this because this kind of like ties it all together in terms of why policymakers and economists alike care about these issues. because we need to understand not only how prices affect actual consumption, but then how the actual consumption and the prices affect physical well-being, if that's what we're after at the end of the day. So we're going to break for questions for 10 minutes, and after the question period, we will resume for the exercise. All right, we'll get going on the exercise and then we'll finish up for the day. So for the exercise for this particular class, I'm just going to have you practice some simple math in terms of calculating elasticities, just so you can kind of start understanding how the mechanics of it work. So the problem I'm going to give you is, suppose you observe two price and quantity coordinates. The first is that at a price of $100, 2 units are demanded, and the second is at a price of $50, 4 units are demanded. Okay, there's going to be 3 numbers that you're going to have to provide for your participation score. Number 1, I would like you to calculate what the elasticity of demand would be if you made the assumption that the $100 that resulted in 2 units was the initial coordinate. And then after that, the second coordinate was a combination of $50 and 4 units. Okay, number 2, I would like you to just switch the order of the coordinates and then calculate the elasticity of demand again. So for number 2, assume that the $50 and 4 units comes first. And then after that is the $100 and 2 units. If you do this correctly, then you should get a different number for the elasticity of demand for questions 1 and 2. Finally, what I would like you to do is I would like you to calculate the arc elasticity of demand. Again, the arc elasticity of demand is useful because you get the same number no matter which coordinate you treat as the first and which one you treat as the second. So for number 3, suppose you don't know which coordinate came first, calculate the arc elasticity of demand. So again, just submit your 3 numbers by the end of the class time, and that will be your participation score.